Testing in staging environments might seem like a good idea, but more and more platform teams and DevOps engineers are realizing that it often causes more harm than good. The problem? Configuration drift, the gradual divergence between staging and production environments that leads to unreliable testing and unexpected issues in production. As engineering teams evolve and their product changes, modifications are made to both the configuration and infrastructure of an application. Over time, these differences stack up, creating inconsistencies between environments. What works in staging might not work in production, making testing unreliable and increasing the risk of undetected bugs, as well as costing your team time and money. Imagine an engineer gets paged in the middle of the night due to a production incident. After checking the logs, they identify the issue and make a quick configuration change to fix it. The problem is solved, but now the production environment is different from staging. The change wasn't replicated in staging, meaning future tests in staging won't reflect the real-world behavior of production. This cycle repeats over time, widening the gap between environments and eroding trust in the staging setup. The more testing and production environments drift apart, the less reliable testing becomes. Eventually, teams stop trusting their testing environments entirely because the results don't translate to real-world scenarios. This leads to wasted time, debugging in staging, unidentified production issues, and a slower, riskier release process. One effective way to avoid configuration drift is by applying infrastructure as code, or IaC, principles. Instead of manually updating environments, define infrastructure and configurations in code. When changes are needed, modify a central definition that consistently updates all environments, making it tightly coupled with your CI/CD integration. Infrastructure as code tools like Harness IaCM can also check existing environments for drift from their desired state and bring them back into compliance. They can offer continuous monitoring and automated remediation to make sure your infrastructure stays aligned with your defined configurations. This reduces human error and ensures production and staging remain in sync. These tools can also proactively manage costs by providing cost estimations for proposed infrastructure changes, allowing you to optimize spending before deployment. You can also enforce OPA-based policies to prevent unauthorized changes and enforce compliance, further reducing the risk of drift. Another approach is to reduce dependence on pre-production environments and use progressive delivery strategies, including feature flags or canary deployments to test in production safely. Instead of relying on a staging environment that may not match production, these techniques allow teams to release changes incrementally, control who sees new features, and roll back instantly if something goes wrong. This removes the risk of configuration drift while accelerating the deployment process. Progressive delivery and infrastructure as code gives teams the confidence to deploy without relying on outdated staging environments. By embracing these strategies, engineering teams can reduce risk, ship faster, and focus on building great software instead of managing environment inconsistencies. If this helped clarify the risks of configuration drift, hit the like button and subscribe for more insights on modern software development. See you next time.